The first method is supervised learning, where we teach AI using data that already contains the correct answers, what we call labels. Think of it like teaching a child by showing them flashcards with both pictures and the names written underneath. Imagine training an AI to filter emails. You show it examples of emails labeled as spam or not spam, and it learns to predict whether a new email is spam or not. Or, picture an AI learning to distinguish between cats and dogs. You give it photos labeled as cat or dog, and soon enough, it can tell them apart on its own. Supervised learning isn't just about categories. It can also predict continuous values through a process called regression. For instance, an AI can analyze data like house size, location, and number of rooms to estimate house prices. Or it could use weather data to predict tomorrow's temperature. Supervised learning is like giving AI a teacher. It learns from examples and becomes smarter over time. Now, let's talk about unsupervised learning, where we don't provide any labels or answers. Instead, we let AI explore data on its own and discover hidden patterns. One approach is called clustering, where the AI groups similar items together. Think about a music streaming app analyzing listening habits to group users into categories like hip-hop lovers or jazz enthusiasts. Another approach is dimensionality reduction, which simplifies complex data. Imagine your photo album automatically extracting only faces from pictures to save storage space or create visual summaries. And then there's association rule learning, where AI finds relationships between items. For example, in retail, AI might discover that people who buy bread often buy milk too, helping stores recommend products more effectively. Unsupervised learning allows AI to uncover insights we might never have noticed ourselves. Next up is reinforcement learning, where AI learns by trial and error, guided by rewards for making the right decisions. An AI playing chess learns strategies by trying different moves and receiving rewards when it wins games. Or imagine an autonomous car navigating traffic. It learns how to drive safely by being rewarded for avoiding collisions and reaching its destination efficiently. Reinforcement learning is all about teaching AI how to act in complex environments, just like how we learn through experience in life. Semi-supervised learning. Sometimes, we don't have enough labeled data for supervised learning, but still want some guidance for the AI. This is where semi-supervised learning comes in a mix of labeled and unlabeled data. In the medical field, only some patient records might have diagnoses attached. Semi-supervised learning allows AI to use these few labeled records while analyzing the rest of the data to improve disease detection models. It's like giving the AI a partial roadmap while letting it figure out some paths on its own. One of the most exciting methods is transfer learning, where an AI takes what it has already learned in one area and applies it to another. An image recognition model trained on general photos can be fine-tuned to analyze medical X-rays for diagnosing diseases. Similarly, self-driving cars can use data from one city to adapt quickly to driving conditions in another city with minimal retraining. Transfer learning allows us to build on existing knowledge rather than starting from scratch every time. Next is self-supervised learning, a cutting-edge method where AI generates its own labels from raw data without human intervention. Language models like GPT learn by predicting missing words in sentences, enabling them to generate text or translate languages with remarkable accuracy. Similarly, an AI might take black and white images and learn how to restore their original colors, all by itself. This approach mimics how humans learn through observation and deduction. Finally, there's multi-view learning, where AI combines multiple sources of information for better results. In e-commerce, an AI might analyze both product images and customer reviews together to recommend items more effectively. In healthcare, combining X-ray images with MRI scans can help doctors make more accurate diagnoses. By merging different perspectives, multi-view learning enables richer insights and smarter decisions.